Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning and welcome to this morning's Signpost webinar. Signpost webinars are brought to you by Teagasc in conjunction with Food Drink Ireland Skillnet, Dairy Sustainability Ireland and National Rural Network. My name is Pat Murphy and I'm with Teagasc as Head of Environment Knowledge Transfer. This morning for questions we're joined by Padraig Foley. Padraig, you're welcome.
Morning, Pat. Thanks for having me.
And we're delighted to welcome this morning Bob Rees. Bob is Professor of Agriculture and Climate Change at SRUC in Edinburgh. Bob, you're very welcome.
Good morning. Thanks, Pat. It's a pleasure to be with you today.
Great. You might just give us a little bit of background to your role and the work you do with SRUC and across the UK.
Sure, yeah. So my background is a soil scientist. That's from a long time ago. But more recently, I've been working quite extensively on sort of climate change research last 10, 15 years or so. And I head up the Carbon Management Centre at SRUC, which is a group that sort of tries to put together the climate change the work we do across different sectors. So we work in livestock, crops, soils, economics, and all of these areas have an interest in climate change research. So one of the things that we try to do there is to bring these things together in an integrated way.
Okay, and a few years ago, the topic you're talking about might have been seen as very blue sky. Now it's become very real.
Absolutely, yeah. It's rarely out of the news these days, isn't it? And you know, our research is really sort of dominated by this issue at the moment. So it's a really important thing for us.
Okay, well, listen, we're looking forward to your presentation. If you want to share your presentation and take it away. Sure.
Okay, so it's a real pleasure to join you this morning. Grateful for the invitation to talk at this seminar series. I offered to give a talk on the implications of net zero for UK agriculture, which seems a pretty topical issue at the moment. Climate change is rarely out of the news, and the need to reduce greenhouse gas emissions in order to avoid catastrophic climate change is becoming increasingly apparent. But maybe what's less familiar is the important role that agriculture and land use are going to contribute in terms of actually committing to the solutions for climate change. So COP26 finished in Glasgow earlier this month. But in many ways, the work that we're doing is just at the start in terms of the fundamental changes that we're likely to see in response to climate change. The UK government have established ambitious and legally binding targets for greenhouse gas mitigation, and agriculture and land use are going to be a critical part of that. So I think it's worth thinking about how quickly things have changed in recent weeks and months. Climate change, as you say, used to be a sort of academic discussion. But these days, that's changed. It's real and it's affecting communities across the planet. Public discussion and debate is recognising this, and calls for decisive interventions in policy have become much stronger. But the question is, which policies and which interventions do we require? Understandably, a lot of the media attention around COP26 was on fossil fuel consumption and mitigation of that, but agriculture and land use make up about a quarter of our greenhouse gas emissions, and they're going to be critically important in terms of delivering solutions to climate change, particularly since they're also able to remove greenhouse gases from the atmosphere. And in recognition of this, the final communique of COP26 included an article that perhaps has been less apparent than some of the others, that said it invites parties to consider further actions to reduce by 2030 non-carbon dioxide greenhouse gas emissions, including methane. So this is very directly targeted at agriculture, where most of the greenhouse gas emissions come from methane and nitrous oxide. Now, the UK has set legally binding targets to reach net zero emissions by 2050, and these have been laid out before Parliament in carbon budgets extending to 2040. And this is going to require deep cuts in emissions across all sectors of the economy. But there's a recognition that some sectors will be unable to completely decarbonise. And the two real problem areas are agriculture and aviation. There's little prospect that either of these sectors will be able to completely remove emissions by 2050. So the solution to this is going to be offsetting by carbon removals. I think at this point, it's just worth reminding ourselves what we mean by net zero. Net zero is the point at which greenhouse gas emissions are balanced by removals from the atmosphere. So these are targeted at a country level, not at individual enterprises. And greenhouse gas removals need to offset the residual emissions that I was talking about in agriculture and aviation sectors. Now, there are going to be different ways of meeting the net zero targets, which is dependent on the implementation of policy. And these are various scenarios that have been suggested by the Committee on Climate Change, which is an advisory body to government on climate change policy, for how the net zero target can be met by 2050. So we will see the zero line going through the center of this graph with emissions that remain across the economy represented above zero. So the two sectors that you see there that are predominant are agriculture and aviation. As I said, there's a few residual emissions from some of the other sectors. But in order to get to net zero, any emissions above the line need to be offset by removals below the line. So below the line, we have land use and land use change contributing to some removal of emissions, and the black part of the bars represent other greenhouse gas removal approaches, which I'm going to come on to say something more about in a moment. But what you will see from this graph is that there are various scenarios. The first of them is the sort of central scenario, the one that we're aiming for, but there are other potential possibilities, some which involve slower progress towards net zero than others. And if there's slower progress, we're going to need more removals to offset the remaining emissions. But one thing's for sure, and that is there's going to be implications of these policies for land use. Those removals of greenhouse gases are going to be heavily dependent on the way in which we manage the land, and they're going to involve land use change towards more forestry, hedgerows, agroforestry, and biomass production. Now, given that we only have a finite amount of land, that's going to involve a reduction in the amount of cropland, permanent grassland, and temporary grassland that we've got available. So this is a major shift in the way in which we use our land that's going to have to occur very rapidly in the next 20 to 30 years. There has to be a recognition that agriculture and land use are different to other sectors in a whole variety of ways. So first of all, most other sectors contribute to greenhouse gas emissions through the combustion of fossil fuels. So they're engineering type emissions. Agriculture and land use contribute to biological emissions. And the greenhouse gases they produce are not CO2, by and large they're methane and nitrous oxide. We're also in the agriculture and land use sector dealing with both emissions and uptake, which is different to most other sectors. And we have to consider that food production is a basic human need. So when we start making changes in this sector, we have to be cognizant of that. And the fact that there are wider socio-economic implications of the way in which we change farming systems. And perhaps in recognition of this, agriculture has been behaving differently in the past to other sectors. So we actually have seen very little change in greenhouse gas emissions from the agriculture sector in the UK over the past 10 or 15 years. In fact, they've been pretty static. And this has been a concern in policy. So the Committee on Climate Change commented in the most recent report to Parliament that progress in agriculture and land use has repeatedly failed to meet the indicators outlined by the committee's progress reports in recent years. But this is going to have to change because in order to meet the net zero targets that have been set down in law, emissions from all sectors, including agriculture, are going to have to fall steeply. So what's been happening in order to help achieve this? Well, let's just go back 10 years or so. One of the reasons that we've had so much difficulty in reducing emissions from the agricultural land use sector is that it's been difficult to quantify them. And until you can quantify the emissions, it's very difficult to actually do anything about them. So around 10 years ago, the UK government set up a large programme of research called the UK Greenhouse Gas Platform Programme, specifically aimed at improving our understanding of the measurement, modelling and reporting of greenhouse gas emissions. And there were programmes of work on nitrous oxide, methane and data synthesis and reporting. This programme was really important in improving our understanding and quantification of emissions. So it resulted in a large output of research that, for instance, was able to specifically quantify the emissions of nitrous oxide from different fertilizer sources and at different locations and in response to different climatic conditions. And this work has been, I know it's been repeated, we've worked very closely with colleagues in Ireland to help them do a similar programme of work, and this has been really important for the two countries working together to help develop an improved understanding of where we are with emissions. So this work, for instance, has led to new spatial maps of emissions. This is a map of nitrous oxide emissions across the UK in grassland and arable situations, grassland on the left, arable on the right. And here we see a very sort of direct response of these emissions to climatic conditions. So in the wetter parts of the UK on the west side, we get a larger response in terms of emissions per unit of fertilizer applied than we do in the east. And this representation has now been implemented in our reporting of greenhouse gas emissions at a national scale in our national inventory using a tier 2 reporting system. And that's been really helpful, I think, in terms of helping to direct policy and think about where we get the best opportunities for greenhouse gas emission mitigation. So building on that improved understanding and in response to the policy commitments the government have made, the government published its strategy to implement these policy commitments just in October last month. It's amazing how quickly things are moving. So this is the UK government's net zero strategy to reach its net zero targets. This is a strategy that provides the detailed implementation of the policy across all sectors of the economy, but including agriculture. What does it have to say about agriculture? Well, the first thing to say is that it includes agriculture as one of the sectors needing to make deep cuts in emissions. So we're looking by 2050 in the agriculture sector to reduce our current emissions from over 50 million tonnes of CO2 equivalents per year down to somewhere in the range of between 10 and 20 million tonnes by 2050, with progressive progress towards that target over the next 30 years. So this is a marked change from, as I say, what we've been seeing over the past decade, where we've seen flat emissions, and were these policies not in place, it would be anticipated that the emissions would remain static or actually rise. So there's a very ambitious pathway there to reduce emissions in the agriculture sector. So what are the proposals that this strategy suggests for agriculture? Well, there are a whole range of proposals, some of which are very specific and targeted, others are more general and enabling. So for instance, there's support for financial incentives to improve animal health and welfare, grants for new slurry stores and other interventions, talk about better use of manufactured fertilizer. But then there are more general and enabling sort of parts of the strategy around support for low carbon farming practices, which are not defined in the strategy, increased investment in research that will need to be done in order to support the strategy. So there's an indication here, in my view, that actually we don't have all the solutions yet. There's a lot more needs to be done. So what is it that we need to do? So getting deep cuts in emissions from the agriculture and land use sector isn't going to be easy. We can break this down into some of the low carbon farming approaches that are mentioned in the strategy that are not specified, but these are things that to those of us that work in the sector would be probably quite familiar. And probably the top line of these would be getting improved efficiency, because improved efficiency gets better use of resources, can also achieve lower greenhouse gas emissions and better economics. So it's a sort of no-brainer really to start in that area. But we're going to have to go a long way beyond that to get the sort of emission cuts that we're talking about here. So we're going to have to look at things like alternative cropping and farming systems, the use of smart farming and technology, vertical farming, better use of nitrogen use, etc. And these are examples of sort of supply side measures that we can implement. But we're going to have to go beyond that. We'll need inevitably to look at demand side measures, so meat and dairy production, whether or not that's going to get replaced by other forms of production such as lab meat, insect protein, legumes, or whatever is going to be open to debate. And there are going to have to be big land use changes. One of the things hidden in that strategy is the importance of biomass and bioenergy to our energy production systems. That's all going to have to come from the land. It's going to be linked to some of these demand side measures where we're sort of changing the demand and therefore changing the land use. And so in principle, this is going to lead to fundamental ways in which our land is being used. But how do we actually get started on this route down the sort of change to these low carbon farming practices and achieve the mitigation that we're looking for? So one of the ways that we've been looking at this is to look at what we call marginal abatement cost curves, which are ways of linking the cost effectiveness of mitigation measures to the amount of carbon that they will save. So we can plot out individual measures on these MAC curves and think about how much they're going to cost and how much carbon will be mitigated by them. And that's what this graph represents. So this graph is a few years old now, and we update these on a regular basis, but I think it indicates the principle quite well, which is that there are a bunch of measures represented on the left-hand side of this graph that actually achieve carbon savings and also economically provide economic savings at the same time. So these are the sorts of things that you'd implement first, and they provide a sort of ranking of measures, that the order of measures that you would introduce them in. And the number of measures that you would include would depend upon the cost of carbon at a particular point in time. And as we move forward, we're expecting carbon costs to increase, so more of these measures would become economical. So you see right in the center of this diagram that, for instance, afforestation is a particularly important strategy for mitigating emissions, given the magnitude of emission savings that it can achieve. So just an example of one of those measures, the use of legume-based grasslands or multi-species swards would be a particularly useful approach in the UK. We have relatively few leguminous pastures in the UK. Most of these have been replaced by monocultures. So increasing grass cover swards would decrease fertilizer nitrogen requirements, reducing N2O emissions, and providing a reasonable saving in terms of CO2 emissions. And I think this is something that's really going to take off next year, given the astronomical increase we've seen just in the last few months in fertilizer nitrogen prices. So we're going to be watching this very closely. When we think about individual measures, we're never going to get the magnitude of emission reductions that we're looking for the net zero strategy. So we thought we'd ask the question, well, what would a typical farm need to do to get to net zero within the farm gate, within the boundaries of the farm enterprise? Now, this is somewhat of an academic question because I said earlier, the net zero policy doesn't actually require individual farms to reach net zero, but we thought nevertheless it would be an interesting exercise just to think within the farm gate as to what could be done or whether it was even possible for an individual farm to get to a net zero position. And the way in which we chose to do this was to use a model, the AgriCalc model that we work on at SRUC, which is a farm carbon calculator type model. And what we did was we took what would be a typical farm enterprise in lowland Scotland, mixed farm enterprise, estimated the greenhouse gas emissions from that enterprise, and then introduced a sequence of mitigation actions in order to bring down emissions, in order to understand what the residual would be for offsetting. So here we are. This graph shows the progress of this sort of approach. So on the left-hand side here, you see the net greenhouse gas emissions from the baseline farm, around 1,300 tons of CO2 equivalents divided between methane, nitrous oxide, and carbon dioxide. And what we did was we introduced a sequence of measures sort of based around this marginal abatement cost curve type approach, so ranking them in terms of the economic priority to try to reduce emissions. So we started off by improving fertilizer nitrogen recommendations, and we had a sort of program of improving productivity in the beef enterprise. We did some work on methane inhibitors using 3-NOP to reduce methane emissions. We introduced legumes into the pastures, and that was the one that had the biggest effect actually in reducing emissions. So you see, as we move from left to right on this graph, the emissions keep coming down. We then added some nitrification inhibitors to the nitrogen fertilizers and did some improvements in grassland productivity, which freed up a bit of land for afforestation. So once you get to that penultimate bar, you're left with the residual emissions, which are still quite high. There's still over 800 tons of CO2 equivalents per year. And that's the bit then that you need to start offsetting. So the light green bar at the bottom is the afforestation. Even putting some woodland into the farm still didn't get us to net zero. And one of the assumptions in this exercise was that we were going to try to maintain productivity on the farm, so we didn't want to affect that. So the last option that we used was the implementation of biochar. This is partially combusted organic materials. So we'll be using straw on the farm to create biochar, which is incorporated into the soil, and that then gave us sufficient carbon offsetting to offset that residual emission. These efficiency measures that I talked about at the start, well, a lot of them we'd probably be doing anyway. They're worth doing. They're cost effective. They achieve inhibition of emissions. Some of the other mitigation strategies, 3-NOP, for example, is a bit more difficult. It's not commercially available at the moment and probably quite expensive. Increased use of legumes makes sense. And as I say, as the price of fertilizers goes up, this is probably something we're going to see quite commonly. Nitrification inhibitors at the moment are a bit expensive, but they do have a significant impact. Some of these other things, such as the land use change, it works, but it takes up quite a lot of land. And the biochar option that I mentioned, again, it works in theory, but it's phenomenally expensive, so not something that's currently practical. So that was an interesting exercise. I've been talking sort of UK-wide at the moment. I just thought I'd say a few words about what's happening in Scotland, because agriculture and greenhouse gas mitigation is a devolved responsibility in the UK. So Scotland's actually committed to reducing its greenhouse gas emissions across all sectors of the economy to net zero by 2045. We had to be ahead of the UK, of course. It's also developed a strategy for this, and it looks very similar in many ways to the UK strategy, targeting things like manure storage, with a transformation program, adoption of low carbon farming techniques, and so on. Again, we're lacking a lot of detail in this part of the program. I think we need to know more about how this is going to be implemented and what the impacts on mitigation are. And indeed, there is a concern in policy because we seem to have a gap. Current agricultural emissions in Scotland are about 7.5 million tonnes. The target by 2032 is to get that down to 5.1 million tonnes. By implementing the approaches we have in the policy at the moment and using all the economically viable approaches to agricultural mitigation, we can get down to about 6.5 million tonnes by 2032. So there's a pretty big gap in the ambition, well over 1 million tonnes of CO2 equivalents. in terms of that policy commitment. And agricultural greenhouse gas emissions in Scotland have been failing to meet the targets that we've already set in the recent reports. So mitigation is only one side of the approach to net zero. The other side is greenhouse gas removals. So can greenhouse gas removals save us? The most familiar of these is carbon sequestration. And there's a lot of hope that carbon sequestration will come to the salvation of agriculture in terms of approaching net zero. And indeed, I mean, carbon sequestration is a very important thing to do. There's almost no downside of carbon sequestration. If we can get more carbon into soils, we gain in lots of ways. We gain in terms of greenhouse gas mitigation, but we also gain in terms of soil quality and productivity. And there are basically two things we can do to try to get more carbon into soils. We can reduce losses, or we can increase inputs, or we can do both. And there are lots of measures, such as optimizing stocking density, improving crop rotations, managing pH, soil quality, and so on, that we can implement to try to achieve this. And these will undoubtedly contribute to important contributions to carbon sequestration. But I think we have to be careful about being over-optimistic about this. A lot of these measures are things that have already been done or tried, or if they haven't been, there are reasons why they haven't. And achieving large-scale removals of greenhouse gas by carbon sequestration may be challenging. And this graphic maybe illustrates part of the problem. One of the things that we do in Scotland and elsewhere in the UK is carry out inventories of carbon storage in soils. So in 1978 and again in 2009, there was a regular grid of carbon storage analysed across the whole of the UK. This is on a grid square basis of 20 kilometres, very detailed inventory of the amount of carbon that was contained in all our soils and different land uses. And it showed that over this 30-year period, the changes in carbon stocks in arable and grassland soils were virtually zero, not significantly different from zero. There were a few small changes in woodland and moorland soils, but in our agricultural soils, the carbon stocks remained the same. So it suggests that in order to increase the carbon stocks in these soils, and our soils are already rich in carbon, may be quite a challenge. But there are other greenhouse gas removal technologies that are available to us. And one of the big ones that the UK government is putting a lot of hope in is biomass energy carbon capture and storage. And this is where we produce biomass by planting trees, short coppice rotations, and other biomass sources that are combusted and used to energy production. But the key part of this is that the CO2 that's released from that energy production isn't released to the atmosphere, but rather is buried in underground storage reservoirs. So this helps to sort our energy supply problems and contributes to greenhouse gas removals. But of course, there are big land implications for this because a lot of this bioenergy production is going to have to take place on existing farmland. So there's a question of how we resolve that within a wider land management strategy. There are other potential approaches to carbon removal from the atmosphere, so things like mineral weathering, direct air capture, ocean uptake and biochar. These are much more uncertain. The potentials that they have for carbon removal are highly uncertain, and the technology is in early stages of development. So given that these have to be implemented at such short scales and on using such large scales of removal, I think there's questions around some of these techniques and what they can contribute. That said, the UK have made projections about where they see carbon removals taking place going towards 2050. And you'll see that a lot of the heavy lifting here is done by biomass energy carbon capture and storage. The red and yellow bars on this diagram represent that removal technology. So that's where they see a lot of that removal taking place. And remember, this is essential to offset the residual emissions that are coming from agriculture in particular and aviation. And interestingly, on this graph, you'll see that the brown shaded area, which is soil carbon sequestration, is contributing relatively little to the overall greenhouse gas removals, less than 5 million tonnes between now and 2050. So I think I'll wind up here, and just to say that the pathway to net zero in the UK is going to require deep cuts in greenhouse gas emissions across all sectors of the economy. But for agriculture, this is still going to result in significant residual emissions remaining by 2050, despite cuts in agricultural emissions. And the challenge is that we're going to need multiple technologies. We're going to need soil carbon sequestration linked with forestation, biomass energy, carbon capture and storage, and other technologies to get that offsetting to work. But the overall message here is that the land use sector is going to be critical in delivering this. And we're going to see big changes in this sector in coming years if we're going to be successful in achieving it. And there are all sorts of questions that sort of spill out of this. I mean, a lot of the technologies for mitigation are still in the process of development. We need to develop those. We need to think about how we're going to actually develop a land use strategy that accommodates the changes that we're going to take place. We need to think about how some of the measures are going to interact with greenhouse gas mitigation. So there's a lot to do. But I'll finish there. I'm happy to take some questions. Thank you for your attention. And if you're interested in this topic, just mention a little flag for a meeting that we're organising in March next year in Edinburgh across the UK on greenhouse gas mitigation in agriculture, organised through the Association of Applied Biologists. So thanks for your attention.
Thank you very much, Bob. A lot to think about. Just, I suppose, sorry, to remind people, if you have questions, would you put them in the Q&A? We have a good few questions coming in already, and might just, a couple of the bigger ones that are coming in. There's a question there just asking about the balance between working towards net zero and UK's self-sufficiency in relation to food products, and where does that sit in the policy environment?
Mm-hmm. Yeah, that's a great question, and I wish I could answer it. I mean, because there's a danger in all this, isn't there? That the easiest way to remove emissions in the agricultural sector is just to close down agriculture, because I mean that's a completely perverse policy incentive, because that by doing that you wouldn't reduce greenhouse gas emissions globally. You'd simply import products from elsewhere, which would probably be associated with higher emissions. So I think, and I've asked that question to DEFRA, and they say their response to that is that they are aware of the problem. But they've never given me a convincing answer to how they're going to solve it. And I think it's a really important issue, because I know in the past the Treasury have looked at agriculture and thought, why do we need UK agriculture? It's a trivial contribution to the UK's economy. Couldn't we just get rid of this sector and import our food? I think recent problems with supply chains, Brexit, COVID, the rest of it have changed policymakers' attitudes. And I think the UK actually has an opportunity to actually lead by example in terms of agricultural transformation here as well. I mean, we've got a very well organized and highly advanced sort of agricultural industry. We're respected for the research that we do. Other countries look to the UK for example. And I think another thing to say is that, as climate change kicks in, northern latitudes, places like Northern Europe, are going to be more important to the global food supply than they have been in the past. I mean, the predictions for the Mediterranean are of significant changes to the climate, which are likely to threaten productivity in that area. So maintaining productivity in northern regions such as ours, I think, would be really important.
And move from, I suppose, a very generalist question to a very specific one relating. You had the maps there of the nitrous oxide losses from soils. a question there as to whether that reflects or whether that takes into consideration the difference in cropping in the two areas, or is it purely, or is it a kind of I suppose the impact of crop taken out of that? Is it purely down to the wetness of the soils, etc.?
Okay, so it was based on regression equations that looked at the nitrous oxide emission in response to rainfall and fertilizer amount, and those were done separately for grasslands and arable areas.
Okay.
So it's principally driven by two things. It's the amount of fertilizer, recognizing that the response is a nonlinear one, and it's the wetness. So they take into account annual rainfall.
All right, I'll hand over to you for some more questions.
Yeah, just on your, thanks very much, Pat, and thanks very much, Bob. Lots of compliments coming in on a nice, clear presentation and lots of information in there. Just to add to Pat's question around the food security element of things, you said that carbon sequestration can be land hungry and that it'll use a lot of land. Have you looked at the impact of that on food production in the UK or in Scotland?
The impact of what, sorry?
The impact of additional carbon sequestration and the measures that you outlined on food production itself.
Yeah, I mean, not directly. I mean, there's a lot of literature out there suggesting that carbon sequestration or improved carbon stocks in soils are the key soil quality indicator. So, you know, one of the things we know is that if you go back over the last century, the loss of carbon from our soils has been driven principally by land use change. So the conversion of grasslands and forest soils into arable soils and tilled soils has been the thing that's contributed to carbon loss. But getting that carbon back is difficult. I mean, one of the problems you have here is that there's a sort of asymmetry. It takes a long time to build carbon stocks in soils, but it's very quick for those carbon stocks to be lost. So those arable soils that we've got that have lost carbon, I mean, we could get carbon back into them, particularly if we're going for a land use change, but it would take time.
Okay. Biochar, Bob, why is it so expensive to produce? Like there's a comment here, can farmers not make their own biochar with farm waste materials? All you need is a barrel, fire, and an oxygen source that can be regulated, essentially a large barbecue. So why is it so expensive, Bob?
I think that's right. I mean, the reason it's expensive is because it's really just sort of experimental at the moment. And, you know, you're right, it could be done in that way. And I think if the policy was to sort of support that, we could see the costs falling dramatically. Now, there are some parts of the world where this actually happens. So in China, for example, there is commercial production of biochar from rice straw, and farmers are using that to incorporate it into their soil, not principally as a greenhouse gas mitigation option, but to improve soil quality, because there's evidence to suggest that you get better nutrient utilization and improved soil quality as a result. And this was the reason that, you know, in South America, biochar was produced and incorporated into soil to improve soil fertility. So I think if we got a policy steer to sort of promote this, that could happen quite quickly. There are concerns. I mean, there are regulatory concerns, because once we put biochar into soil, we can't take it out again. And if we find at some point in the future that that wasn't a good idea, then we're in a difficult place. But you know, I think we're in a difficult place anyway, and there are probably some solutions that we're going to have to implement that we may not have initially thought of being viable.
Okay, well, here's one that wasn't mentioned. There's a lot of questions here around wetting or re-wetting lands. Much of our peat bogs are farmed or owned by farmers. You know, have you looked at re-wetting them and the impact of that on your net zero calculations?
Absolutely. So, I mean, that's a critical part of the strategy. And I didn't mention that because we sort of think of that as being outside the agriculture sort of area. But I mean, in Scotland, we have large areas of degraded peatland, and those are a critical part of delivering sort of carbon removals that we're expected to see. So, and it's less important in England, but it's something they're considering. But yeah, so it's certainly there in the strategy.
Okay, and any thoughts on how that might impact on biodiversity in the same regions?
Yeah, that's an important point, because I mean, wetland restoration and creation is an important part of the biodiversity strategy as well. So you know, you get the win-wins. But in terms of sort of agriculture, the sort of agricultural production systems, I mean, it's relatively minor because production in those areas is quite small.
Then back to biochar briefly, just a similar comment here. You've mentioned the biochar obviously, but the incorporation of straw into soils to increase the organic matter, is it having much of an impact, or can it enhance the carbon neutrality?
Well, yes. So, I mean, so if you have a sort of cereal-based rotation, straw is incorporated into the soil on an annual basis. But the problem with straw incorporation is that over a period of time, you get to an equilibrium where the amount of carbon going in is equal to the amount of carbon coming out again. And straw is pretty sort of decomposable material. So, you know, if you look at the amount of carbon remaining from a straw incorporation a year later, you'll see that a lot of that carbon, more than half the carbon, has been lost. And then in subsequent years, the rest is lost. So converting straw into biochar is a way of locking that carbon in, essentially, because if you convert the straw into biochar, instead of seeing 50 or 60% lost in 1 year, you see virtually nothing lost. And if you do that year after year, you gradually build up the carbon stock.
Okay. Just a kind of a, I suppose, more of a question on the demographic that you're working with. Are the UK farmers buying into the proposed changes, or what kind of reaction are you getting from farm organisations or lobbyists?
Yeah, I think there's a lot of support for this. I mean, farmers are very keen to support the net zero agenda, and NFU in the UK is suggesting that they can get ahead of the UK policy. I think the difficulty is that the policy implementation needs more clarity. So, and there's a lot of things happening here. I mean, with Brexit now, we're moving outside of the Common Agricultural Policy. So the replacement for that policy is still in the process of development. There's something called the Environmental Land Management Scheme that's being introduced, with Sustainable Farming Initiative payments replacing the single farm payment. And those are being directed now towards low carbon farming activities. But we're still waiting to see what that initiative is going to involve. There's supposed to be an announcement next week on the Sustainable Farming Initiative. And that, as I say, is going to be targeted at some of these low carbon farming practices. But exactly how that targeting works, we don't know. And I think this needs to happen quickly.
Okay. And from an advisory or a KT perspective in disseminating, just sticking with the farmers and getting that information out to farmers, what's happening on the ground with the SRUC advisory services, or broader SRUC?
Yeah, so I mean, that's a really good question. So farmers are very keen to engage with this. They understand the urgency, the importance. I mean, we're doing a lot of work with farmers. We've got a couple of things going on. There's Farming for a Better Climate, which is a programme supported by Scottish Government, looking at trying to introduce low carbon farming measures, introducing carbon sequestration and reducing emissions. So this is about providing very targeted support for individual farm enterprises and getting groups of farmers working together on this, with free support and advice, carbon footprinting and investment in new farming technologies. And then the other thing that we're doing is we're rolling out carbon footprinting across, we're trying to roll this out across all farms across Scotland and probably more widely across the UK, for farmers to be able to understand where they sit in terms of a carbon footprint, to benchmark their enterprise against similar enterprises in that sector, and to think about sort of specific interventions within their farm that can be introduced to try to reduce emissions. I think that's really helpful because unless you know where you sit within the sort of emission spectrum, it's very difficult to sort of shift your emissions and do mitigation.
Yeah, a good question and a detailed answer. We've got, of the more than 300 people that are on this morning, we've got some very good senses of humour. Anyway, one person wants to know, will you be working with Jeremy Clarkson? And he's obviously buying into it. So the kind of theme that we're getting, there's two splits in the camp. One group wants to know, are the targets high enough for agriculture? Are we pushing farmers hard and far enough? And another group are wondering, why aren't we tackling travel? It's mostly done for pleasure. There's Boeing 747s going across the sky. So the responsibility has to be placed on people to maybe stay at home and not be traveling as much if they want to eat. Have you any views on striking a balance there?
Well, as I said, I mean, aviation and agriculture are two sectors that can't completely decarbonize. I mean, I think it's a good point about travel. Some of us were pretty disappointed to see the UK Treasury recently reducing taxation on internal airfares. I mean, that seems like a retrograde step in terms of transport, because we should be focusing more on surface-based transport. For the agriculture sector, I think, there is a recognition that we have to produce food, and food is inevitably going to be associated with emissions. So I think there has to be a residual emission that we offset. I think that's perfectly reasonable. The big questions are around what sort of food it is we're going to produce and what sort of level of meat consumption is going to take place in 2050. That's a big debate. So the Committee on Climate Change's modelling is suggesting a 20% reduction in meat consumption, meat and dairy consumption, in order to meet their target. And that balance between meat and non-meat consumption has a big impact on the overall greenhouse gas emissions. So that's, I think, where sort of a lot of debate is taking place.
Bob, a couple of questions there. I suppose one fairly direct one should be relatively fast. How far are we from an internationally recognised standard for measuring carbon sequestration?
Well, there are, I mean, the IPCC put down the guidelines for reporting and measuring greenhouse gas emissions, and that includes measurements of carbon. So we have internationally recognized standards. What I think is interesting is now the way investment banks and big investment companies, pension funds, are getting interested in agriculture as an opportunity for carbon offsetting. I think one of the things they feel limited by is the sort of monitoring, reporting and verification approaches that we're using. I think they're developing very quickly on the basis of that research I was talking about. I think there's a potential there for a lot of money to flow in from the private sector alongside government funding to support some of these investments that we need for low carbon farming. And we're not quite there yet, but I think that MRV approach is getting pretty good, and it should be available within the next few years.
So another question there, are two questions. What are, if you were to in 1 minute, highlight the key priorities for research going forward and the key priorities for policy going forward?
For research, for research, I think we still need a better understanding of how we can apply some of the sort of developing technologies for mitigation and sequestration. So improving our understanding of spatial variability in landscapes, targeting fertilizer applications, targeting feed in livestock. These sorts of things can potentially give us more efficient use of resources. The policy is still far too vague. We need to understand how the funds that are going to be invested in agriculture that are being moved away from the production subsidies into the low carbon subsidies, how they're going to be targeted. And there's a lot of investment. The MAC curves that we've done tell you that there's a lot of potential at the high end for expensive measures to actually reduce emissions. So things like the biochar, acidification of slurries, spatial management, smart management in farms, all these things get expensive, but if we've got the funding, we can implement these. So that's where the policy needs to move.
Padraig?
Yeah. Can Scottish farmers move to producing food for a plant-based diet and cut back on animal agriculture? I think you probably commented on the Highlands yourself, and maybe you stick the map up again. This will reduce greenhouse gas emissions significantly. Why is the reduction of cattle numbers not mentioned in a presentation like Irish agriculture attitude to this question?
Yeah, so lots of questions in there, aren't there?
Yes.
So yeah, we can move towards more plant-based foods. I mean, but one of the things we could also do is provide more protein security within the country. So we're heavily dependent on soya imports into the UK to feed our livestock industry. Using more home-based protein sources to supply that would help reduce global greenhouse gas emissions by avoiding deforestation in tropical areas. Why did I not mention reduction in cattle numbers? Well, I've mentioned it in the chat. I mean, it's part of the more general strategy. The government policy on this is still to be formulated. If you read the net zero strategy, it doesn't really mention it. The Committee on Climate Change, which is the advisory body, is very convinced that it's going to be necessary to meet our net zero targets. So, I mean, that's a very live discussion at the moment.
Your 300-hectare farm that you did your research on, would that be considered, was it intensively stocked, or what was the stocking rate on it? And would it be considered an average farm in Scotland?
Yeah, we tried to represent sort of average conditions, so it was reasonably intensively managed. So it was a mixed beef enterprise with cropping as well.
Your access to, was it protected urea? You said you'd used Dane inhibitors on the farm. Was it protected urea that you used? And did you have any difficulty in sourcing it?
So that was a modeling exercise. It was using nitrification inhibitors with ammonium nitrate rather than urea. Yeah.
Okay. You said we need to be very careful about being optimistic about what we can do. Can you say a little bit more about that? Or are you?
Yeah, well, I think I was referring there specifically to the carbon sequestration issue, because I mean, I hear a lot of talks on this area, and some of them seem to think that carbon sequestration is going to be our savior. But I mean, I just worry about that, because if we're going to maintain agricultural production in the way that we've been doing, and even with the implementation of some of these low carbon farming measures, it's going to be difficult to achieve massive rates of carbon sequestration that we require to get that offsetting. And the way I see it, and I think this is where Committee on Climate Change and others are looking at it, is that successful implementation of bioenergy production and carbon capture are likely to have bigger potential. But it's just, I mean, that does still worry me, because carbon capture, it's still a theoretical concept. It hasn't been implemented at large scale. We desperately need that very quickly.
Okay. Can you
say?
Sorry,
yeah, there's a question in there alluding to the potential role for a land use strategy and how you might, I suppose, put the power behind the land use strategy to get it implemented.
Yeah, I mean, I think the land use strategy is an interesting one, because this is what we're really missing. I mean, we're seeing sort of government support for individual policy initiatives, investment in particular technologies and so on, that talk about bioenergy. But, the modeling suggests that the sort of things that we're looking at here are going to require large scale land use change. And for me, there doesn't seem to be a strategy that guides that. I mean, we're leaving this to individual enterprises to make decisions about how things are implemented. But what is the policy? What is the government policy for land use strategy? I don't see that being spelt out in real detail, and that is a concern.
Okay, the burial of CO2 from burning the short rotation coppice woods, is there any implication on acidification of groundwaters from the conversion of CO2 to carbonic acid? Or maybe even from intensive monoculture forestries? Is there?
Yeah, I mean, well, as I say, the technology is still in a stage of development, so it's difficult to know exactly what the answer to that is. But I mean, theoretically, it's possible to avoid that. So the CO2 that's captured should be buried in reservoirs such as those that have been used for natural gas. So we've taken natural gas out of underground reservoirs. There's no reason why we can pump CO2 back into it. A lot of the technology is available from the oil industry to do that. The sort of old way in which we used to burn biomass and produce sulfur dioxide and acid rain, I mean, that problem is solvable. We can clear up the flue gases that come out and remove the acidification from them. So the CO2 shouldn't be getting into the water, nor should SO2 be getting into the atmosphere. But as I say, we need that technology to be developed.
Okay,
I think we've hit our wall. I think there's plenty more questions still to go, but Bob, you have been really concise and really clear in the questions, and I'd like to thank you for that. I think a lot of positivity about your presentation, about the clarity and the quality. So thank you very much for your presentation.
Great, thank you very much. It was a pleasure.
So just to say that next week we'll be joined by Catherine Keena in relation to planting hedgerows, and this is the start of the Teagasc Hedgerow Week, which will take place between the 6th and the 10th of December, where there'll be a series of webinars looking at a lot of different elements of hedgerows and their importance. And I suppose we'll have renewed interest in that. It looks as if one of our eco scheme measures is now going to incorporate hedgerows, so there may be a higher degree of interest in relation to that. Before I finish, I'd like to thank our production team of Yvonne Marr and Andy Boland, and thanks to you, the audience, for staying with us, and we'll see you again next week. Thank you.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.